A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Uh, the topic for our today's discussion is how to carry out a hypothesis testing using confidence interval estimates. Dear students, in the previous lecture of the confidence interval estimate, we have stated that we construct the confidence interval along with the point estimates to decrease the uncertainty and to make point estimator a reliable and appropriate representative of the population parameter. Again, we have stated in the previous lecture that we can also do the hypothesis testing through confidence interval approach. And today we will do the hypothesis testing through the confidence interval approach. Look at the model before what we have estimated yet now. The population parameter estimated by point estimator by using the following equation. We have estimated the following equation where the population regression function is y is equal to beta naught plus beta 1 x plus mu, and population regression line is beta naught plus beta 1 x, and the estimated regression line is y cap is equal to beta naught cap plus beta 1 cap x, where beta naught cap plus beta 1 cap are the estimates of the population parameters beta naught and beta 1 cap, and we have estimated these coefficients through ordinary least square by employing the point estimator formula. Now we will see how we do confidence interval through we will do hypothesis testing through confidence interval approach. The hypothesis testing has the same 6 steps. We have previously studied the test of significance of the coefficient through t test and z test. We stated the 6 steps. These 6 steps were: number one was construction of null and alternate hypothesis. Number two, selecting an appropriate level of significance. Number three, selecting an appropriate test statistic. Number four, delineating the critical values. Uh, if we have two tail tests, then the critical values will lies on the both right and left tail. If there is a one tail test, the critical values will lie on only right or left tail. But how we will determine it is one tail single tail test or double tail test depends upon our null hypothesis. If null hypothesis is h1 is equal to 0 not 0 sorry is equal not 0, then it will be two tail. If h1 less than or greater than 0, then it will be a one tail test. We start with our basic steps now. The confidence interval as a hypothesis testing. How to carry out a hypothesis test using confidence interval. The step one is calculate the value of beta 1 cap and standard error of the beta 1 cap, as we stated before. In the last slide, I stated that we have calculated the beta cap, beta 1 cap or beta naught cap through the point estimators through using ordinary least square. So the first step in the hypothesis testing through confidence interval test is to calculate the beta 1 cap. Suppose we're using beta 1 here and standard error of the beta 1 cap before. Step number two, formulate the null and alternate hypothesis. Uh, to determine the significance of the uh, estimated coefficient, we construct the hypothesis, and in the null hypothesis usually we state that there is no significant relationship between the independent variable and the dependent variable. This insignificant connection between the two variables state that beta 1 cap is equal to 0, that particular beta I is equal to 0. Beta I is equal to 0 mean that the x doesn't impacting the y, mean that x is unable to affect the y. There is no statistically significant relationship between x and y. And then first we formulate the null hypothesis, then we collect evidence to reject the null hypothesis. Our main objective in the in the hypothesis testing is to reject the null hypothesis. And then if there are not enough evidence, we accept the null hypothesis, and if there are sufficient evidence, we reject the null hypothesis, and there is an alternate hypothesis which is based on the uh, theoretical uh, theoretical knowledge between the relationship of the variable. Here the alternate hypothesis H1 is beta 1 is not beta 1 is not is equal to 0. This is uh, mistakenly stated here. So the alternate hypothesis will be here that beta 1 is not equal to 0, mean that beta 1 either is negative or positive, but it is significant. The h1 is mistakenly written here that beta 1 is equal to 0. The h1 is beta 1 is not equal to 0, and coefficient is not insignificant, but if beta 1 is not equal to 0, then coefficient will be significant. Here the alternate hypothesis will tell us that our critical values will be on one tail or on both tails. Here in this case, when we assume that beta 1 is not equal to 0, it means it can either be positive or negative. So it can occur on both tails. So the critical values will be on both tails if the alternative hypothesis is like this, that beta 1 is greater than 0 or beta 1 is less than 0, then the critical values will be on the one side. Step 3, choose the significance level alpha. Again, in economics, we use 5%. This is equivalent to choosing the 1 minus alpha into 100% the confidence interval. The confidence interval here will be 95%. That we are 95% confidence that our population parameter value will lies between our confidence interval. The step number 4 is use the t table to find the appropriate critical values, which will again have t minus 2 degree of freedom. Here we will use t table because we doesn't know the population variance and population standard deviation, and as well our sample size is less than 30. If our sample size was greater than 30, or we knows the population variance and standard deviation, then we have to use the z test. Here t minus 2 mean t minus k, n minus k. T is represent the n, that is total number of observation, and 2 represent the number of coefficient that we have estimated through regression line, that is beta naught and beta 1. And then we will calculate the confidence interval is by the formula that we have previously discussed, that we have to calculate the two limits. One is positive upper limit and the other is lower limit. The upper limit will be calculated by the formula on the right hand side, beta 1 cap plus t alpha by 2 into standard error of beta 1 cap, that is that beta 1 cap plus t alpha by 2 and standard error of beta 1 cap. This is the upper limit of the confidence interval, and the lower limit will be calculated by beta 1 cap minus t alpha by 2 into standard error of beta 1 cap. This is the lower limit of the confidence interval. Now how we'll decide about that, either we have to reject or accept null hypothesis. Now we have constructed the range of the confidence interval, and we will examine that is our null hypothesis fall inside the confidence interval range, mean that we see on the previous slide that our null hypothesis was beta 1 is equal to 0, right? Mean that the coefficient value equal to 0 if 0 if 0 falls in the range of confidence interval, if confidence interval encompasses the 0 in itself, then we will accept the null hypothesis, and we state that the beta 1 cap, yeah, beta 1 is insignificant statistically, and there is no relationship between independent variable and dependent variable. If 0 doesn't lies between the range of the confidence interval, then we will state that the null hypothesis is rejected. And when null hypothesis is rejected, it's mean that the coefficient is statistically significant and there is a significant relationship between the independent variable and dependent variable. 6. Inference of the test. If the hypothesized value of beta, that is hypothesized value, mean that what we hypothetically assume in null hypothesis lies outside the confidence interval, then reject the null hypothesis. And if the hypothesized value lies inside the confidence interval, then we will accept the null hypothesis or don't reject the null hypothesis. This was the hypothesis testing through confidence interval approach. Our next lecture comprises the blue properties of the uh, ordinary least square estimates, where we will in depth study what are the blue properties, and we will prove the blue properties. What it mean by blue? B for best mean that the OLS estimates has lower variance, least variance. uh, E is uh, sorry, L for linearity, that is the the coefficients are linearly dependent on the observations. And unbiasedness mean that is expected value of the estimated coefficient are always equal to the population parameter. So we will meet in the next class with blue properties, inshallah. Allah Hafiz. Assalamu alaikum.